It's one of the most fascinating questions you could ever pose, one that humanity has been asking from the beginning of time. What lies beyond the bounds of current understanding? What is beyond the limits of our maps? What is outside the edge of this cosmos is the final answer to this query. The answer is, well, it's complicated. What is the universe? Curious to know more? Now let's get deeper into this. Hello everyone and welcome to our channel. Don't forget to subscribe to this channel and press the bell icon to never miss an update. Let's start the video. Before we can answer what lies beyond the cosmos, we must settle on a standard definition of that term. There cannot be anything outside the universe if you define it as everything that might possibly exist in all of space and time. Whatever you imagine outside the cosmos must also be a part of the universe, even if you assign the cosmos a numerical volume. All the objects in the universe, including a blank, featureless, nameless expanse, are included in this definition of universe because nothing is a thing. If the cosmos is unlimited in size, you don't need to worry about this problem. Being all there is, the universe is infinitely huge and has no edge. Thus, there's no exterior to even talk about. Oh, indeed, there is an outside to our observable region of the universe. There is a limit to the universe's age and the speed of light. In other words, we haven't seen the light from every galaxy in the cosmos. The present span of the observable cosmos is around 90 billion light years, and presumably there are many more random stars and galaxies beyond that barrier. But past that, it's hard to tell. The curvature of the cosmos. The cosmologists aren't clear if the cosmos is infinitely massive or just exceedingly large. To quantify the universe, astronomers instead look at its curvature. The geometric curve on the gigantic scales of the universe teaches us about its general shape. Infinite space exists only in a flat, mathematically perfect cosmos. Like Earth, a curving space indicates a limited volume. The cosmos appears nearly flat based on current observations and measurements of its curvature. You could believe this means the universe is infinite, but it's not that simple. A flat world doesn't imply that the universe is infinite in size. As an illustration, consider the outside of a cylinder. Despite having a limited dimension, it is geometrically balanced because parallel lines drawn on the surface stay parallel. This is one definition of flatness. The same may hold for the cosmos. It's possible, perfectly flat, yet has a closed interior. A finite universe, however, does not imply the existence of a boundary or limit. Our universe may be a tiny part of a much bigger, multi-dimensional structure. That's okay, and part of some eccentric versions of physics. But today we have no method of testing it, and it doesn't alter the cosmos's day-to-day operations. Even though the universe has finite volume, it need not be embedded. And I know this statement causes a lot of pain. Everything depends on how you view it. If you try to picture the cosmos, you can show a considerable sphere studded with stars, galaxies, and other astronomical wonders. You may imagine how it seems from the outside, how an astronaut watches Earth from a calm orbit above. However, the cosmos can function very well without any outside input. The universe is, defining a three-dimensional universe without requiring an outside, is perfectly compatible from a mathematical standpoint. Mathematically, seeing the cosmos as a ball floating in nothing is a mental trick. Granted, a finite cosmos with no exterior seems implausible. Not even nothing as an empty emptiness, completely mathematically undefined. It's like asking, what does the color purple make? In response to the question, what's outside the universe? It's a ridiculous question because you're trying to merge two unconnected notions. Possibly outside exists in our cosmos. Again, though, this need not be the case. Nothing in the mathematical description of the cosmos necessitates an exterior. Don't worry if it's confusing. Advanced math gives us tools to solve challenges beyond our imagination. Current cosmology lets us study previously unreachable issues. This is it, everyone. So what do you think? Leave a comment and let us know. Thank you for watching the video. Don't forget to like the video and subscribe to the channel if you haven't already done that. Also, put on the notifications because the following video is going to be a great one.